In this video, I'm going to show you 3 different ways you can sketch quadratics in standard form without completing the square. So completing the square you can always do. If you want to sketch quadratics, that's great. Completing the square is a way that you can find vertex form. And I showed you in the last video in this series how you can sketch a quadratic if you've got vertex form. But what I really like about quadratics, and what I'm really excited about teaching this unit, is that there are many different ways you can think about quadratics, and there's always many different things you can do with a quadratic, all of which makes sense and all of which will give you various features that you might want. And so I thought I'd show you some different ways that you can sketch a quadratic depending on which is most convenient for that particular form that you get. And so we're going to look at 3 different standard form quadratics, each of which has a different nice method, all of which are easier than completing the square, in my opinion. So I'm not saying you have to do it this way. You can always complete the square to get your vertex and then use your Y-intercept method that I showed you in the last video. But sometimes you don't need to do that. So let's look at this example here. F of x is 3x squared minus 5x plus 2. Now, those are really small numbers. So I think that I can just factor this using a method called inspection. So inspection works like this. There's only 2 things that can multiply to 3x squared if this factors. And those are going to have to be 1 and 3. And then there's really only 2 possibilities here. To get 2 is going to be 1 times 2. So one possibility would be to put a 2 here and a 1 here. And if I was to multiply this out to find my middle term, I need to get a negative 5. So I guess I'll need both of them to be negative. And let's see what happens in this case. 3 times negative 2 is negative 6. 1 times negative 1 is another negative 1. And negative 6 and negative 1 would make negative 7. Okay, so that's not going to work. So let's swap those around this way. So now let's try this. 3 times negative 1 is negative 3. 1 times negative 2 is negative 2. And negative 3 and negative 2 gives you negative 5. So there you have it. We've just factored this by inspection. And factored form gives us our zeros really nicely. So x, remember the idea of this is that your factors will equal 0 only if this factor is 0 or this factor is 0. That's a 0 property of quadratics. So if I imagine 3x minus 2 equaling 0, that means that my negative 2, if I was to solve this, would need to go to the other side of the equation to become positive 2. And then I'm going to need to divide by my coefficient of 3. And this one is just a straight x equals 1 because 1 minus 1 is 0. One other thing that we can do to sketch this, so we've got our x-intercepts, so we can sketch those right now. But 2 points don't really make a very exciting graph, as we will see. So we've got one x-intercept here at 2/3, and we've got another x-intercept here at 1. There's actually a really easy point that we can graph as well. The y-intercept in standard form is one of the easiest things to find. We're going to substitute 0 for x, right? Because on the x-axis or on the y-axis, x is 0. And 0 times anything is 0. So this term is going to disappear, this term is going to disappear, and we're going to be left with positive 2. So we know that our y-intercept is up here at positive 2. So that's enough information. We can do a sketch. So let's fill in our parabola shape. So it's going to go up there, it's going to go down to here, and it's going to go up sort of this way over here. And by symmetry, I suppose we can fill in another point. This point here is sort of 2/3 over to this x, to this point on the x-axis. So sort of if I fill that in here, which means that by symmetry, if I go another 2/3 over, I should get another point here. And that's going to be 1 plus 2/3 is 1 and 2/3, comma, the same value 2. Now often though, we care about the point at the bottom of a parabola, the vertex. And again, by symmetry, this vertex is going to be exactly halfway between my x-intercepts. So let's figure out our vertex by averaging our x-intercepts. So our vertex x value you need to average 2 points at the same height. And in this case, the most convenient ones are going to be our two x-intercepts, the 2/3 and the 1. So to average those two values, we're going to need to add them up, 2/3 plus 1, and divide by 2. So 2/3 plus 1 we're going to need to turn into 3/3. So 2/3 plus 3/3 is 5/3. 5/3 divided by 2. Dividing by 2 means you need to add another 2 in your denominator, which is going to make this sixths. So 5/6. So the vertex is going to be 5/6. And then the y value I don't know. But how do you get a y value? Well, the same way we got our y-intercept, by substitution. So let's substitute this value into our function. F of 5/6 is 3 times 5/6 squared minus 5 times 5/6 plus 2. So this is 5 squared is 25. The 3 I'm not going to actually deal with, and I'll show you why in a sec. The 3 I'm going to leave there because 6 squared is 36. And if you notice, 3 goes into 36, leaving us 12ths. So then my next term is minus 5 times 5 is 25. But I know I'm going to want 12ths, so let's just do this to 12ths right in this step. So 5 times 5 is 25/6, which I need to double to get 50 12ths. And let's turn our 2 into 12ths as well. So 2 in 12ths is going to be 2 times 12 is 24. So we add this up. 25 plus 24 is 49. 49 is 1 less than 50, so it's going to be negative 1/12. And so the y value of our vertex is negative 1/12. Cool, so there we have it. We've got our x-intercepts in this case we got from factored form, which was really nice and easy to do because these numbers were all nice and small for us. We were able to get our y-intercept just straight out of our equation from this plus 2 on the end. And we were able to average our 2 points to find the x value of our vertex and substitute that point in to get the y value of our vertex. So one that factors nicely, you can just factor, find your x-intercepts, go from there. Okay, what if it doesn't factor? So let's do g of x is, let's do 4x squared minus 24x plus 10. So if you try to factor this, you take 4 times 10 is 40. Is there anything that multiplies to 40 and adds to negative 24? So it's going to be two negative numbers, obviously. But 40 and 1 would make 41. 2 and 20 would make 22. And if you lower your factors any lower than that, you're going to get a smaller and smaller sum. So this doesn't factor. You can't factor this quadratic. So let's talk about how we can get our vertex using the quadratic formula. So if you recall the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. And if you think about that graphically, what that means is you have, some pair of zeros, one here and one here. And the 0 over here is negative b plus the square root of b squared minus 4ac all over 2a. And the 0 over here is negative b minus root b squared minus 4ac all over 2a. Now if you average those two, in the middle, your plus root b squared minus 4ac and your minus root b squared minus 4ac are going to cancel each other, and you're going to be left with negative b over 2a. And so what this tells us is that the x value of the vertex is negative b over 2a. And then if that's the x value of the vertex, how do you get the y value? So then the y value of the vertex is f of negative b over 2a, right? Substitute that x value you just found into your function, and you will get the y value of your vertex. So let's try this with g of x. That's our b value, that's our a value. Okay, let me just write this out again. So g of x is 4x squared minus 24x plus 10. And so our b value is negative 24, and our a value is 4. So then the x value of the vertex is negative b over 2a. And in this case, negative 24 is positive 24. And 2 times our a value of 4 is 8. 24 divided by 8 is 3. So then the y value of our vertex is going to be g of 3. So let's do that substitution. 4 times 3 squared minus 24 times 3 plus 10. 3 squared is 9. 9 times 4 is 36. 24 times 3 is 72 plus 10. 36 is half of 72, so that'd be negative 36. Negative 36 plus 10 is negative 26. So my vertex is 3, negative 26. And my y-intercept is 10. So let's sketch this. Okay, let's draw some axes. Let's sketch it right here. Okay, nice small graph. So 3, negative 26. I guess I'll put here. This is 3, negative 26. And my y-intercept is 10. And this is 3 over, right? To get to 0, I went 3 over. So another 3 over will bring me to 6, and then the same y value, 10. And there you have it. I've got 3 points for my parabola, g of x. All right, let's try one more method. This is my favorite method, this last one. Let's call this h of x, because why not? Let's just keep working our way through the alphabet. Give everyone a chance. So h of x is 4x squared minus 32x plus 55. Maybe that factors, but 4 times 55 is 220. That's a really big number, which I don't want to deal with. So what I'm going to do is I'm going to common factor 4 and x out of these two terms. And what that leaves us with, 4 reduced by 4 is nothing, well, 1, I guess, and then x squared reduced by x leaves an x behind. And negative 32 reduced by positive is minus, 32 reduced by 4 is 8, and x reduced by x leaves you with no variable. So it's just negative 8. And then the plus 55, whatever, you can just stay out here. Now, what's really cool about this form is this is essentially factored form with an extra bit on the end. So we can actually think of setting this equal to 0. So if we have 0 equals 4x and x minus 8, right, and ignore the plus 55, then this will never equal 0. This equals 0 if x equals 0, and this equals 0 if x equals 8. But this isn't our equation. H of x isn't 4 times x minus 8. It has a plus 55 on the end, which means this isn't going to equal 0. This is going to equal 55. So if x is 0, this whole thing disappears, and we're left with 55. If x is 8, then this thing is 0, so this whole thing is 0, and we're left with 55. And so we can sketch that. What this says is that if x is 0, then y is 55. And if x is 8, then our function is 55. So 8 comma 55 and 55 on the y-axis, 0 comma 55, are 2 points in our parabola. And as we've seen right back in our first example, we can then figure out our vertex is exactly halfway between those two. So let's figure out h of 4 to find the y value of our vertex. So h of 4 is going to be 4 times 4 squared minus 32 times 4 plus 55. Now if we work this out, that's 64 minus 128. So 64 minus 128 is negative 64. Negative 64 plus 55 is 9. Negative 9. So there's our point here at 4 comma negative 9. Connect that into a nice smooth parabola. Let's pretend I went through the y-axis there. And there you have your h of x. I love quadratics. So the point of this video isn't so much any of these particular methods. The point of this video is the fluency of all the different things you can do with quadratics, all of which make sense and all of which work. So our first method, we factored. Once we had x-intercepts, we averaged to find our vertex. Our next method, we took the idea of this quadratic formula, this beautiful, wonderful quadratic formula that you've all memorized by now, I'm sure. And that tells you 2 zeros. So if you average your 2 zeros, you can get the x value of your vertex. And the last one we did some really cool factoring, where we factored an x out of x squared and x, giving us our y-intercept, essentially. Our y-intercept then was 0 comma 55. And then we took our second term, our binomial with x, and got a symmetrical point on the parabola. And once you've got two symmetrical points, just like what we did in our first example, once you've got two symmetrical points, you can average them to find your vertex, just like what we did at the top.